Okay, children. Today our topic is the continuation of the yesterday's work. Today we are going to learn about the area between two curves. So we have already learned the theory contents based on that. Uh, area between two curves. Right, okay. So we already learned the theory contents as I mentioned in the yesterday's session. So today we'll start with this question. So here we are going to discuss with this point. So this curves y equals to x squared plus 2 meets y equals to 6 at point A and B. Initially, we need to find the coordinates of A and B. Apart from that, we need to find the shaded area over here. This bit of area we need to find it. Now let's see how to do this question. Right. So initially, the shape they have given is just like this, and it's a curve y equals to x squared plus 2 meets the line y equals to 6 at 2 points A and B. They need to find out the region enclosed over here, right? So initially what they want is they need to find the intersection of this curve with this straight line, right? So how do you find this intersection? That's the important part we have to understand. If you need to find the intersection between two curves, two straight lines, or curve with a straight line, whatever, we can find them by solving a simultaneous equation. X squared plus 2 and this is y equals to 6. So you can say this is the first equation and this is my second equation. With that you can say x squared plus 2 equals to 6 by making first equation equal to second equation because both the terms are the y, right? Therefore x squared is equals to 4. Therefore x become plus 2 or x become minus 2. That's a fact we have to understand. So in this situation, so here 2 minus 2, sorry, and this is plus 2, right? Okay, now what you need to know is we have to identify how to find the area, right? So initially, like if you want to get this yellow color area, how can we do? So what you can do is for answer B, initially I will get this rectangular area just mention over here. So that is y equals to 6 from minus 2 to plus 2. I will consider this area. How do you get this area? That is pretty simple. You can use two techniques. The first technique is you can, first technique is you know that here the length from here to here is how much? 4. And the height y equals to 6 means height is 6. That means you can get this area by 4 into 6, 24. If you are unable to figure out this 24, there is another technique you can do. You know that it's a curve of y equals to 6. So you can write, you can integrate the curve y equals to 6 from minus 2 to plus 2. So it's done up to 6x from 2 to minus 2. That is 6 times of 2 minus 6 times of minus 2. That one also 24, right? Then I'll find out the area under this curve. So the next part is just like this. I'll just consider this part of it with it. So if you integrate this graph from minus 2 to plus 2, what do you get? You get this area. Always this integration shows you the area between the curve and x-axis. So this area A2, I'll just consider this one as A1, A1, A2. A2 would be the integration from minus 2 to plus 2, this curve. the curve is x squared plus 2. So if you do this integration, that is turn up to x cube over 3 plus 2x from 2 to minus 2. So if you do this substitution, you will receive the answer. Just substitute and see. Initially substitute the first, the upper bound 2, that is 2 cube over 3 plus 2 times of 2 minus substitute minus 2. When you do the substitution, remember that you have to put a bracket for these negatives. So you will receive this answer as, let's see what is that fact. Integration from minus 2 to plus 2. That answer become 40 over 3 today. Then, yeah, this answer is 40 over 3. Then how do you supposed to find the shaded area? So if you need to find the shaded area, what you can do here, if you just, if I refer these ones, out of this rectangle, if you remove this bit of it, so what you can understand, you can say, you can obtain this yellow color area. So simply out of this rectangle, so if you just out over here, out of this rectangular area, this bit of it, from, if you remove this part of it, if you remove this part of it here, then you can get this area. Therefore, simply you can see the shaded region R. I just consider this area as R. So you can assign any letters for this one. It's not a problem at all. So this R, you can say A1 minus A2. So simply you can write that is A1 minus A2. A1 is 24 minus 40 over 3. So you can get the final answer for that. That is turned out to 32 over 3. So you can keep this answer in this format unless they ask about some significance points of the answer. So other than that, you can keep the answer in this format. Right? This is pretty simple, right? So that is the first question, that is exercise 8D. Exercise 8D, question number 1, right? Okay. So now let's move to the next question. This page is not enough, so I'll go to another page. So, sorry. Yeah. Then if you come up with the question number 2, right? Okay. The question number 2 is just somewhere like this. So that is, it's a graph like this over here. That is y equals to 3, and this is the next part is y equals to 4x minus x squared. So they are referring to this region R over here. We need to find the region R. So initially to find the region R, what you need to do is we have to identify the coordinate of A and B. The x coordinate is the required ones. So how do you find the coordinates of A and B, Pute? So you can say at A and B, you can to find the coordinate, you can simplify these two equations as simultaneous equations. So simply you can say this is 1 and this is 2. So since this is y and y, so you can equate 1 into 2. So you can write 4x minus x squared equals to 3. So if you brought all the terms to one side, minus x squared plus 4x minus 3 is equals to 0. So from here, you can get these answers, but you need to simplify these equations and get it. Yeah. You need to work out this question and to get it. Other than that, you won't get the full marks for this question. So anyway, I just get it. So the x coordinate is equals to 3 and the other one is 1. So but you can understand now here Here the x coordinate is 1 and here the x coordinate is 3, right? Okay. Then how do you find this area? That's a fact we have to understand, right? Okay. Then initially part B, this is part A. Yeah. Then if you work out with B, initially I will integrate this straight line from 1 to 3. 1 to 3. So what is the area you receive? If you integrate it from 1 to 3, you get an area somewhere like this. Here the height is, the line is y equals to 3. Therefore, this height is 3 and here the length is 1 to 3, that is 2. So this area become 3 times of 2, that is 6. That's the first part you can understand, right? Okay. Then the second graph is just like this. Then this is the important point where you need to understand, right? The graph was somewhere like this way around. My handwriting, just writings are not that accurate. So it's just a point over here, 1 to 3. So that is the point we need to understand. If you do this integration from 1 to 3, you have to clearly understand what is the area enclosed. From 1 to 3, area between the curve and the x-axis. That means you are receiving this area. That is the fact you need to understand clearly. Right. So that A2. This is just A1 and this is A2. A2 is integration from 1 to 3. 4x minus x squared. That is 4x minus x squared. So if you do this, that is 4x squared divided by 2 minus x cube over 3 from 1 to 3. So this is turned up to 4 and 2 get cancels. 2 times of 3 squared minus 3 cube over 3 minus substitution of 1 to the 2 times of 1 squared minus 1 cube over 3. So this came by 4 divided by 2 is 2. That is why this 2 came. So if you just get this answer, that is 3 to 1. The function is 4. That answer become 22 over 3. Now what you can understand is if you need to receive this part of it, this kind of answer, if you need to this bit of it answer, this shaded region over here, what you need to do is initially if I get the area over this bit of it, out of that, just sorry, if you get the area over here to here, out of that if you remove this bit of it, you can get the received answer. That means it's pretty simple. The area become A2 minus A1. That is 22 over 3 minus 6. That is 4 over 3 would be the final answer for this kind of a question. So that is the way of answering the question number 2. Right. Okay. Then we will move up to the next question. Yes. Then if you refer with the next question, put it just like this. Question number 3, it's a little bit of, no, not different. Actually speaking, it's, they have given the coordinates of A and B and they mention the second line. It travels to this point. It's a straight line. I just, when I'm drawing, it makes a little bit of crooked. So just don't worry about it. So if you refer with this 4 minus 4x squared. So if I show you the question, this is the one we are referring to. So here the curve is y equals to 4 minus 4x and this is y equals to 9 minus 3x, this part of it. So this is a one. So we need to find the area enclosed over here. And so yeah, 4x squared, sorry, it's not 4x squared, it's just like 4 minus 4x. And this curve is y equals to 9 minus 3x minus 5x squared minus x cubed, right? They are referring to this one, this area. Then with the meantime, they have given the coordinates of A and B. They have given the coordinates here, A. You can understand that they have given the coordinate A is minus 1, 8, and B is 1, 0. Minus 1, 8. So this is minus 1, 8, and this is 1, 0. B is 1, 0. So then we need to find the area over here. So you have to understand that, yes, then if it is minus 1, 0, here the x coordinate is how much? Minus 1, right? Okay. So initially, I will try to find out like this way. The straight line is just like this. Here, they have given the coordinate minus 1 and this coordinate is 1. And from this coordinate, you can understand that this height is 8 and this length is 2. So simply, if you need to find the area enclosed over here, A is equals to, it's a triangle half base. Base is 2 into perpendicular height. Perpendicular height is 8. So it should be 8. That's a pretty simple answer. Or other than that, if you just didn't figure out this fact, we know that the straight line is y equals to 4 minus 4x. Sorry, 4 minus 4x. Therefore, you can integrate the graph from minus 1 to plus 1, 4 minus 4x. If you do it, it's turn up to 4x minus 4x squared divided by 2 from minus 1 to plus 1. If you do it, that one also you receive the same answer, right? Any figure, any way you can use to get this answer, right? Okay. Then the other area, other fact where it's involved with this area is the area under this curve, this part of it. So now you can understand that this is the fact where we need to understand. The graph behavior is like this way around, then minus 1 is here. The scale is not perfect, but just to understand this fact. Therefore, if you integrate the curve from minus 1 to plus 1, what is the area enclosed? This would be the area enclosed by this graph. This is pretty simple, right? So if you, this is the area enclosed by this graph, then you can find this area by, I'll just label this one as A1 and A2. A2 would be the integration from minus 1 to plus 1, 9 minus 3x minus 5x squared minus x cubed, right? If you do this integration, that is 9x minus 3x squared over 2 minus minus 5x cubed over 3, this is 5, minus x to the power 4 over 4. You have to do it from minus 1 to plus 1, right? So you have to substitute this upper boundary and lower boundary. You know how to find the, substitute these figures now. Then if you get this answer, that is 44 over 3 per day. So this is 44 over 3. So that is that bit of it, right? Then if you want to get this required region, what you're supposed to do? Out of this total area, from here to here, if you remove this triangle, then you get the required area. There with that you can say this total area is equals to A2 minus A1, that is 44 over 3 minus 8. That is equals to 20 over 3. That is the final answer for this question. Right, okay, that's a way of doing the question number 3. Right, okay. Right. Then the question number 4. If you move up to this question number 4, what you can understand is, this is question number 4. They have given, find the area bounded by the finite region y equals to 1 minus x and x plus 3 with y equals to x plus 3 graph, right? So, yes, then, yes, the two curves are, the question number 4, the two curves are y equals to 1 minus x plus 3, other one is y equals to x plus 3, right? Then initially we need to draw this graph with it, right? Let's see how to draw this graph. We need to find the area enclosed by these two shapes, right? Okay. Then if I just draw this graph, it's like this, y equals to 1 minus x plus 3 to this. So here you can say that curve is passing through minus 1 intersection of the x-axis. If you want to find the, if you want to draw the intersection of the x-axis, become, if you make y equals to 0, 1 minus x equals to 0 means minus 1, and other one is 3. And it's a cubic graph which is having a positive, negative coefficient of x squared. Here, if you expand it, you get the answer this way, minus x cube plus 2x plus 3, right? Okay, it's a, sorry, x not cube, it should be squared. So it's a quadratic graph with the negative coefficient. That means it's a graph with a maxima. Just like this, sorry, it's handwriting. Just drawing is a little bit of ugly, but just don't worry about it. It's 1, traveling through 1, right? Okay. Then the y equals to 3 axis. So this is a graph of y equals to 1 minus x, x plus 3, and y equals to 3 plus x, x plus 3. So over here, so what you can understand is the graph goes like this way around. Right. There's a small error with that. So if you when you just draw it perfectly, you can understand that intersection of the y-axis means this is 3 and this one also passing through 3. So the perfect graph for this would be like this. Just if you draw it, okay, children. So if you draw this graph perfectly, you can understand this curve traveling from, it goes like this, minus 3 and plus 1. And here the y coordinate also turn up to 3. So the straight line goes through this point. So you can understand that the intersection of this straight line travels over here this way. It's perfectly traveled through this tree. So the area they are referred with is this bit of it. This is the area they are referring to, right? Okay. Then what can you understand here is, yeah, here the x coordinate is how much? Here the x coordinate is 0, right? Initially, I will integrate the curve. Area A1, I'll just get it, integrate the curve, this bit of it, integration of 1 minus x from x plus 3 from minus 3 to 0. Why I'm doing like that? Because you know that they are worrying about the area enclosed from this bit of it. That means that is the area under the curve from minus 3 to 3, right? So if you do this, this is minus 3 to 0, that is, so I have already expanded this bracket. So the minus x squared plus 2x plus 3, or if you just minus x squared plus 2x, sorry, it should be not plus 2x, should be minus 2x, minus 2x plus 3. Yeah, x minus x into x is x squared, minus x into minus 6 minus 2x. So it's not minus, it's not plus 2x, but it should be minus 2x. Right, okay. Then in this case, if you do this integration, you will understand that minus x cube over 3 minus 2x squared over 2 plus 3x from 0 to minus 3. If you do this integration, you will realize that the area become then the area become 9. So if you do this perfectly, it's 9. Then if you need to give this area, what you need to do is, now already found this area under the curve. Now if you remove this triangular area out of this ones, if you remove, like now for the moment we know the everything up to here. So if you remove this triangular area out of the area we have considered at the beginning, so you can get the required area for that. So I just find that area A2, that is, it's a triangle. This triangle, here the base is how much? The base, the length is 3 and the height also 3. So that is, you can say half into 3 into 3, that is 9/2. Or you can use this technique as well. Or you can integrate the straight line from -3 to 0. X plus 3. There even you get the same answer. You just work out, sorry, 9/2. You just work out and see, right? Okay. Then what we need to do is we can find the required area. Then the shaded region would be R would be 9 minus 9/2. That is turned up to 9/2 itself. That is a way of doing that question. Okay. That's how you need to do this kind of situation. Okay. Right. Then if you come up with a question number 5 today. Question number 5. Is just like this. Right. It's just like that. Then the curve given here is, I think it has drawn go more to this side. The curve goes like this way around. Like this, and so I think it's wrong. It's not a angle line, it's a vertical line, horizontal line, sorry. So horizontal line somewhere like this. Yeah. The curve was like this way around, and there is a horizon. And yeah, it's a horizontal line. Just like this way around. They are referring to this region R over here today. So obviously we know that we can find the coordinate over here is 0. I need to find out the coordinate over here. So it's a horizontal one, this line and this point. So how do you find it today? So simply what you can get here is that this line is y equals to 12 and the other line is y equals to x 4 plus x. 4 plus x, so it should be x times of 4 plus x equals to 12, so that is turned up to x squared plus 4x minus 12 equals to 0, so that is x equals to, so you receive the answer as 6, it's minus 6 and x equals to plus 2. So here this is minus 6, but here it should be plus 2 there. Plus 2, then if you need to find the region R, what you need to do is, initially I will integrate the curve. I will integrate the curve from 0 to 2. 4x minus x squared. So that is 4x squared over 2 minus x cubed over 3 from 2 to 0. So if you do this, you will receive the answer like this. That is turn up to 16 over 3 today. 16 over 3. That means this entire, this bit of it. The 16 over 3 means this is the area they are referring to. That is the area between the curve and the x-axis from 0 to 2. That means we are referring with this area. Right. Then the next part of it, I'll try to find out the area of this rectangular part. The rectangular part is, you can understand that this length is 2 and the height here. How do you find the height here? Height here is, this y equals to 12 means this height is 12. So that is equals to 24 today. Then we can find the required area region R is equals to 24 minus 16 over 3. So you get the answer 56 over 3 would be the final answer for this today. That's a way of doing this kind of a question.